Good morning, students. My dear. We have gone through the theorem 6.7 or 6.6. That is ratio of the areas of two similar triangles equal to square of the ratio of the sides equal to ratio of the square of their medians or altitudes. In my last video, I have shown instead of the side, I have shown with the altitude. Okay. Now this one theorem I thought very important because in the perspective of the exam. Now also it has the application as well. So last day we have done few questions with the application of that theorem, and today we'll start with another theorem. And I think last day I have explained, I have given the hint, but still better to do, and that's why I will do once again. So let's see. So in question number 5, it is given that ABC is a triangle. ABC is a triangle. Okay? Then D, A, B, C, D, E, F are the midpoints. Then what you can do, you have to prove that find the ratio of the areas of the two triangles, that is triangle DEF and ABC. Triangle DEF and triangle ABC. Now this particular question, actually in last year, that midpoint theorem we have done by using the midpoint theorem. Now we will not do the midpoint theorem, but we will prove by this property. Okay. So let's see. But also the use of midpoint theorem will be there. Okay. So let's see. Question number 5. So see one thing. First of all, you write ABC is a triangle. D, E and F. D, E and F are the midpoints of BC, CA and AB. Now, to be two triangles. Remember, first you have to write that D, E, F are the midpoints of ABC, of triangle ABC. Now these two triangles. Now then what do you have to do? See, D is the midpoint of BC. If D is the midpoint of BC, then you see one thing, BD equal to DC, yes or not? And similarly, AF equal to FB and AE equal to EC. Yes or not? Now, apart from that, what else you can write? We can write equal to half of BC equal to half of AB equal to half of AC. Yes or not? Because you say D is the midpoint. If D is the midpoint, BD equal to DC. So BD of what? BC. See, DC of what? BC. So BD equal to DC equal to half of BC. Similarly, AF equal to BF equal to half of AB, and AE equal to EC equal to half of AC. Clear? Now, if it is this one, then you see one thing, that next you see, if this is the midpoint, then by midpoint theorem, what is that? The line joining the midpoints of two sides of a triangle is parallel to third side and half of the third side. So D comma E are mid points of BC and AC. Then what happened? DE equal to half AB. DE equal to half AB. Yes or no? Next you see. Next, see EF similarly EF equal to half BC and DF equal to half BC. DF equal to half BC. Now you can see one thing. These things are written, but in this context, actually these three parts will not be needed in this context, but it will be needed if they will ask you to prove that all these four triangles are similar. Then it will be needed. Otherwise, it will not be needed. Okay. Here they are asking only triangle DEF and triangle ABC. So remember, my dear students, see this particular part, that is starting from this to this, actually it will be needed if they will ask you that prove that AEF similar to triangle ABC or triangle BDF similar to triangle ABC. Then it will be needed, otherwise it will not be needed. Okay. So then you see one thing. DE by AB equal to half. EF by BC equal to half, and DF by AC equal to half. See, this is also half, this is also half, this is also half. Then by the rule, what happened? All these ratios are equal in proportion. They are in equal proportion. That means triangle DEF similar to triangle ABC. Then I will rub. So then therefore DE by AB equal to EF by BC equal to DF by AC equal to half. Implies what? Triangle DEF similar to triangle ABC. Therefore, your answer now. AR triangle DEF divided by AR triangle ABC equal to DE by AB whole square equal to 1 by 2 whole square equal to 1 by 4. So see, that means according to the theorem it is supposed to be written DE square by AB square. So DE square by AB square, that by law of indices you got A to the power n divided by B to the power n, it is nothing but A by D whole to the power n. So in that case DE by AB equal to 1 by 2 whole square. So 1 by 2 it came from there. So therefore equal to 1 by 4. So ratio of the area of the two triangle is equal to 1:4. Remember one thing, if it will be given triangle area of triangle ABC by area of triangle DEF, then you have to shift the other way. AB by DE. So it will be 2 by 1 equal to 4:1. Okay? Then thank you. Then let's see next one. Question number 6. Last day during that theorem I told it may be the side, square of the side, it may be the altitude, it may be the median. And this is the question number 6. They are asking that it is the median. We have to prove that the median. Okay? Now, question number 6. Question number 6. See. A, B, C, P, Q, R. This is D. This is M. This one equal to this one equal to this one. Okay? So I think you have written that last part, so now I'll drop this part. Now, please go through the questions once. Please go through the question once. What is asking? They are asking that if prove that ratio of the areas of two similar triangles is equal to square of the ratio of their corresponding medians. So let ABC and PQR, let ABC and PQR be two similar triangles. Let ABC and PQR be two similar triangles. Then, if they are similar triangles, then what will happen? AB by PQ equal to BC by QR equal to CA by RP, and angle A equal to angle P, comma angle B equal to angle Q, and angle C equal to angle R. This thing we got. So this is what you can do. This one is the equation number 1, and other part will be that. Now you have to prove that. To prove what you have to prove? AR within bracket triangle ABC by AR within bracket triangle PQR equal to AD square by PM square. AD square by PM square. Then in that case you see first. So now further, whether we have written this one? Not written. So first you have to write down that one, that AD from A and P, AD and PM are drawn median on BC and QR respectively. From A and P, AD and PM are drawn medians on BC and QR respectively. Now median means what? The line drawn from vertex to the base bisect the base, or line drawn from vertex to the midpoint of the base. So now proof. So there will be no construction, proof, direct proof. What is the proof? Say first of all, AB by PQ equal to BC by Q1. Given? Yes or not? Equal to half BC by half QR equal to BD by QR. Can you write or not? Because D and M are the midpoints, and already I have given the symbol that equal. So BD, instead of D, half of BC is nothing but BD, or DC if you take the other triangle, and half of QR is nothing but QR. And then, so implies AB by PQ equal to BD by QM, and angle ABD equal to angle PQM by 1. Got it? So that you see, we got the ratio of AB by PQ, BD by equal BD by QM, and then angle B equal angle Q. Then what happened? Triangle ABD similar to triangle PQM, similar to triangle PQM. Yes or not? So see, we got two triangles similar. If two triangles are similar, then you see, just like that theorem, AB by PQ equal to AB by PM. AB by PQ equal to AB by PQ equal to AB by PM. Clear? Now let's see. Now I have to rub. So this part I rub. So because angle already you have used, so not needed again. Then you see triangle AB by PQ equal to AD by PM. Okay, AD by PM. Now, if AB by PQ equal to AD by PM, then from here what we will get? That AB by PQ equal to BC by QR equal to CA by RP equal to AD by PM. Then AR within bracket triangle ABC divided by AR within bracket triangle PQR equal to what? AD square by PM square. Because all are equal by the theorem. Okay? By the theorem. Clear? So this is the question number 6. So please write down. Then we'll pass to question number 7. Then we will go to question number 7. Please write down. Try to be fast. This one I'll give the hints. I will not do. You will do. Okay. I'll give the hints. See, according to this question, what is given? Prove that area of an equilateral triangle described on one side of a square is equal to the half of the half the area of the equilateral triangle described on its diagonal. Described on its diagonal. Prove that area of the equilateral triangle described on one side of a square is equal to half of the area of the triangle, equilateral triangle drawn on its diagonal. Okay, so let's see. Square. So draw a square. No, this is the diagonal. Now, They're asking you that equilateral triangle drawn on the diagonal. Then again, another the equilateral triangle drawn on one of its sides. Got it? Suppose A, B, C, D, E, this is 2. Now you have to prove that area of triangle AQC is equal to 2 times the area of the triangle CPB, or area of triangle CPB is half the area of the equilateral triangle drawn on AC. Okay, so first of all you let ABCD be a square, and AQC and DCB are 2 equilateral triangles drawn on AC and CD respectively. Once again, let ABCD be a square. AC is a diagonal. Now, triangle DCP and triangle AQC are drawn on CD and AC respectively. Equilateral triangle drawn on CD and AC respectively. To prove AR within bracket triangle CDP equal to half AR within bracket triangle AQC. Okay, this is the to prove. This one to prove. Question number 7. Got it? Now you see square. What is the definition of the square? All sides are equal and all angles are right angle. And if all sides are equal, then you just imagine, suppose this is x, this is also x, this is also x, this is also x. Then, and this is the right angle. Remember, this is the right angle. So from right angle triangle ABC, we get what we get? AC square equal to AB square plus BC square. Now AC square is equal to x square plus x square. Then what is that? AC equal to root over twice x square equal to root 2x. So we got the side of equilateral triangle and side already given. Then you can you know that what is the area of equilateral triangle? Root 3 by 4 into side square. Root 3 by 4 into side square. So AC is root 2x and CD is x. So then root 3 by 4 will be cancelled. So and x will be cancelled. So it will be 1 by 2. Okay. So please complete it by yourself. Now next, another important theorem, and this is also important in the perspective of the exam purpose. Okay. So please write down this one first, and then we'll go to the next one. Okay. Yeah. Today I'll just explain, I'll not do. Okay? Next day I'll do. Today I'll just explain the theorem. Theorem is that you see this is the right angle triangle. A, B, C. And this is another perpendicular line. Now they are asking in triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. That is, you have to prove that AC square equal to AB square plus BC square. And this one will be proved by using similarity of triangles, Now I'll just give you a hint, you try, otherwise in my next class I will do. See, first of all you take triangle ABB and triangle ABC. If you take triangle ABD and triangle ABC, then you say triangle AD equal to triangle B, angle AB, angle D equal to angle B because both 90 degrees. And then next you see angle A equal to angle A because both. Therefore these two triangles are similar. Then you find out the relation. Okay? So please, then similarly other one also. That is triangle BDC and triangle ABC. So you please try that one by yourself. Otherwise, in my next class, I'll show you how to do. I have just given you the hint how to do. I have drawn the diagram, and please try to solve it. If not possible, definitely I will help you in my next class. Till then, thank you.